Hello. No. Hello. 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 Barang. Just hello.
A very warm good morning to all present here. I, Megha Khandelwal, feel great to extend my Sadhya Namaste to present everyone here. Today, we all are gathered here to celebrate the inaugural function of International Seminar on Indian Mathematicians and Their Contributions 2022. This function has become now a ritual, in fact, a yearly ritual in Department of Mathematics. Also, this seminar marks the celebration of National Mathematics Day. Also, it pays a mathematical ode to the man who knew the infinity, Srinivasa Ramanujan. We feel great that all the eminent guests have arrived here. I would like to ask everyone whether I'm audible. All the participants have joined here with us. through online platform. So am I audible? Thank you. So we will proceed for the functions points today. All the eminent guests are already arrived here, and we are honored to have Professor Bhattu Satyanarayana, Honorable Vice Chancellor, Central University of Karnataka, as the presiding president of this function, a man who is of distinct vision and fountainhead of illuminating ideas and experience. I feel privileged that we have, along with us, the chief guest of program, Professor G. Radhakrishnan from IIT Karnal, who is the chief guest of this program and keynote speaker. Welcome to you, sir. I feel profusely elated to have here with us our very own and dynamic Dr. Deepak Samuel, Dean, School of Physical Sciences. Welcome to you, sir. And we have our very own coordinator of Department of Mathematics and convener of this program, Dr. Srinivasulu Ballam. All the eminent guests have taken their distinguished chair, and now I would like to request Dr. G. Janardhan Reddy, Associate Professor, Department of Mathematics, to present a floral welcome to Honorable Vice Chancellor, Sir, Professor Bhattu Satyanarayana. Thank you, sir. Now, I invite Dr. N. Sandeep, Assistant Professor, Department of Mathematics, to present a floral welcome to the guest of honor, to the guest of the Dean of School of Physical Sciences, Dr. Deepak Samuel. Thank you, sir. Now, I would like to call upon Dr. Devika to welcome the coordinator of Department of Mathematics and convener of the seminar, Dr. B. Srinivasulu. Thank you. So now it's time to mark the inauguration of International Seminar on Indian Mathematicians and Their Contributions 2022. So for this, I would like to invite all the eminent guests on the dais to honor by garlanding Srinivasa Ramanujan's picture and doing deep culture before Master Saraswati.
Next.
Thank you all. So here begins the International Seminar on Indian Mathematics and their contributions 2022. Now, I would like to call upon the convener of the program, P. Srinivasa sir, to render the welcome address. So please.
Respected Honorable Vice Chancellor. Not audible? Yeah, fine. Respected Honorable Vice Chancellor, Central University of Karnataka, Professor Bhattu Satyanarayana sir, Dean, School of Physical Sciences, Dr. Deepak Samuel sir, and today, Chief Guest of the function and keynote speaker, Professor G. Radhakrishnan sir from IIIT Kurnool, and senior faculty members and dear delegates, students and friends, good morning to all. It's my privilege to welcome you all to the 2 days international seminar on Indian mathematicians and their contributions, ISIMC-2022. This seminar, particularly we're conducting this seminar in your these celebrations of National Mathematics Day 2022. The Department of Mathematics, every year we used to celebrate National Mathematics Day on eve of birth anniversary of Srinivasa Ramanujan, and the seminar particularly we used to take an initiation not only to know it. Usually we used to celebrate National Mathematics Day to know it brief history of our achievements of Srinivasa Ramanujan. Along with Srinivasa Ramanujan, would like to know our Indian mathematicians, their contributions and their achievements to the nation as well as to the globe. We're conducting this seminar. So with this in this seminar, I think we received, mostly across the nation as well as the globe, more than 900 participants were registered, as well as more than 10 countries were registered in this seminar. So I appreciate and thanks to the delegates for registering in the prestigious 2 days seminar. Also, firstly, I thank the today's chief guest of the function, Professor G. Radhakrishnan sir, for accepting our invitation in spite of your busy schedule and gracing the inaugural function and ready to deliver keynote address. So and also I feel that happy and blessed to be a student of Professor G. Radhakrishnan sir. And also we are very happy you accept our invitation to become a chief guest of this function. Thank you very much, sir. And also thanks to all invited speakers for accepting our invitation in spite of their busy schedule, and ready to give their invited talks. As well as I would like to first and foremost, I would like to thank our Honorable Vice Chancellor, sir, Professor Bhattu Satyanarayana sir, for when we proposed to conduct the international seminar on history of mathematics. Sir, without any hesitation, he given enormous support to conduct this program and providing the financial support to conduct this program. Without your financial support and encouragement, this program may not be held, sir. Thank you very much, sir. So next, I would like to thank our registrar sir, whenever approached to get the proposal to give it to sir without any second thought, just immediately he also forwarded our documents without making anyone else trouble in the processing our documents, immediately given approval. Thank you very much, sir. And also provide the good facilities as whenever we required, sir, we required anything like, we want to go, particularly we have more than 900 participants, sir. They were unable to provide online platform to the participants. We request, sir, we'd like to give through the YouTube live also then, without any hesitation, sir also given permission. We feel very thank you, Professor Baswaras P. Donur, sir. Next, I would like to thank our dynamic dean. He is given enormous support to us. I think without SAR support, we may not be conduct this seminar also. Whenever we require his support and help, whenever we calling him, then without any second thought, he is supposed to us. I may be with you only. You should go ahead. You can. But whatever we need help there, I try to help like that, given support and encouragement to us. Even though sorry may not be available last 10-15 days, whenever I need help and suggestions, I used to call without hesitation. He given his support and help. He given right constructive suggestions to conduct this seminar, as well as STS are also reached CUK campus. Even though also I request him, sir, kindly come to department. We'd like to take your suggestions to conduct this seminar, since we may not be available last couple of days in CUK. Sir, he came to department. He spent more than 1 hour with us. He discussed with us what are the things we are doing it, how we had to handle it, and given his support. And with that support, I think we were able to organize without any difficulty this seminar, sir. Thank you very much, Dr. Deepak Sembal, sir, for your support and encouragement. Next, I would like to thank our department colleagues as well as our math students for their continued support to conduct this event, as well as to the running of the department. Next, I would like to share few things about the department. The Department of Mathematics was started 2012 with MSc Mathematics program. After that, 2 years in 2014, Department of Mathematics started PhD program. Later, we recently 2022, Department of Mathematics along with Department of the Computer Science, we started BSc Mathematics and Computer Science program as per the NEP policy. Now, we're able to run our department successfully without any difficulty. Our PhD students also, they're doing good research work without troubling. But I feel that they're publishing good number of papers, as well as with the high impact journals. The students are creating in our department a good research environment with the students as well as among the faculties. So I thank appreciate the students as well as the faculty to create good research environment in the department. Next, I would like to I think share about the department few things. I think we have 4 regular faculties, and also we feel that we're having like Dr. Janardhan Reddy. It is a good asset for the department since he was received Inspire Teacher Award from the President of India, and also we feel happy, and we're having like Dr. Sandeep. He was listed consecutively 3 times top 2% world top 2% best scientist in the world, and also this time I think it was this academic year he was listed top 1% top scientist category also. So we feel happy by seeing the achievements of our faculty, as well as hope in the future our students as well as our department faculty, they will perform well. They try to bring the good name to the department as well as to this UK. Finally, I would like to thank everyone for teaching staff for their support and encouragement to the Department of Mathematics. So I request your Honorable Vice Chancellor sir also, not only now, in the future, we require your support and help to smooth running of the department, as well as to perform better way in the academically and research also. Okay, so with the notes, I welcome you all to these 2 days, the international seminar on Indian mathematician and their contribution. Thank you all for giving the opportunity.
Thank you, sir, for the welcome filled with gratitude. Now, I would like to call upon for inaugural address the President of this function, our Honorable Vice Chancellor, Professor Battu Satyanarayana, sir.
Good morning to everyone who are participating in this international seminar on Indian mathematicians and their contributions, organized by the Department of Mathematics, CUK, Professor G. Radhakrishna ji, today keynote speaker, Professor Deepak Shamu, Dean, School of Physical Sciences, Dr. Srinivasulu, the convener of this program, Professor Egadi, Dean, the School of Computer Science, and other faculty members, research scholars, students, participants, and guests. So, today, I'm congratulating the Department of Mathematics for organizing this international seminar on the contribution of the Indian mathematicians. The contribution of Indian mathematicians, that is Indians to the mathematics, is immense. So we cannot forget about this one. And also I pay tribute to the Ramanujan ji, who has contributed a lot for the mathematics. So today the program is organized on his own. So if you look at the contribution of the Indian, that is a contribution, very great contribution by the Indian. So that is and Ramanujam, coming to Ramanujam, he was not in good health and he has come from the poor background. In spite of all this, he has contributed a lot for the mathematics. He is also struggling to find a solution. You see, but he is died at early age. And he lived for more years to have contributed a lot for the mathematics. And if you remember our great ancestors like Aryabhatta, Varamira, Bhaskara, they are great mathematicians and astronomers, and they contributed a lot for this development of mathematics, their calculations, everything. Even today, there is no substitute for that. Even Vedic mathematics, and that is giving a lot of solutions. We can give the solution within no time. Even like a computer, we can do the mathematics calculations by using the Vedic mathematics, because we are ignoring that one. So now this is a time. So I'm advising the Department of Mathematics UK. Just you go to through the Vedic mathematics, and you try to introduce one subject or elective in your discipline, in your curriculum. At least for next academic year, that definitely the students will, at least they will aware what is the Vedic mathematics and what are its uses. And it is time to go to our own mathematics, how it was how this we progressed. Even the Germans, they are doing a lot of research. They are learning the now Sanskrit, and they are finding what are the sort of problems and what are the solutions for problems were available in our old literature. They are doing a lot of research. Now it is time to us to revisit what is there. Just if you look at the Nalanda University, very old university, which was by the foreign invaders. Just if you go through the history, that was born from 3 to 6 months. Just you see how much literature was there and what are the literature, what type of literature. Even then, in those days, foreigners have come to the India to learn many things. Now we are going to the US to learn. So that means in the ancient period, we have a great knowledge, and it is a time to revisit, and we need some young minds to apply and to revisit and what is there in the ancient period and what is the contribution of Indians for mathematics. That is the time. So therefore, I am again advising mathematics, Department of Mathematics UK. You all that's made you introduce this as a curriculum. Definitely, our university will gain lot of name and fame in future. And also, you take the advice like Radhakrishna Krishnamacharya or others also. You invite different persons to the university to bring a name and fame to this university. You contribute a lot for this. Only if you do considerable work, then only the name will come to the department and as well as to the university. That is required. So you should not waste your time. You concentrate more on the academics and try to publish very good papers in good journals and try to give many solutions to the problems of the society what we are facing today. With this, I thank the organizers for giving the opportunity. I thank one all.
Thank you, sir, for your words filled with inspirations. Always your ideas fill the Department of Mathematics with illumination and inspirations to come up in the best possible ways. Thank you so much, sir. Now, I would like to request Dr. G. Janardhan Reddy, Associate Professor, Department of Mathematics, to introduce, listen, hardly need introduction, the keynote speaker of the day and chief guest of the day, Professor G. Radhakrishna, IIIT Kurnool. Over to you, sir.
So, good morning to one and all. So, I feel blessed and honored to introduce a great personality, good human being, and a renowned speaker, and my guru, Professor G. Radhakrishna, being as a professor of mathematics in IIIT Kurnool. So earlier, Sir worked as a professor of mathematics, NIT Warangal. So almost nearly 34 years, and retired in the year educational qualifications. So Professor G. Radhakrishna completed his BSc and MSc from SV University Tirupati and completed PhD from IIT Kharagpur in the area of biofluid dynamics. Sir guided 11 PhD students and completed 2 research projects and published nearly 80 papers in standard international journals. So come to the administrative experience. So Professor GRK sir acted as a co-convener for the ESET in the years 1994 and 95, and acted as a co-convener MSET Andhra Pradesh in the year 1996, served as a head of the Department of Mathematics, NIT Warangal, and also served as a chief warden of NIT Warangal, and also served as a registrar of NIT Warangal, and also served as a Dean Academic Affairs in NIT Warangal, and also Dean Student Affairs NIT Warangal, and also served as a member of Board of Governors NIT Warangal, and also served as a professor in charge Legal Cell NIT Warangal. And come to the special distinctions, Professor GRK sir awarded a cash prize in MSc first year for obtaining highest percentage among all PG programs of SV University Tirupati, and also secured the first rank in MSc in SV University Tirupati. And also, sir acted as a member expert committee appointed as per the directive of the Honorable High Court of Andhra Pradesh for supervising the verification of answer sheets of the prestigious MSET examination during the period 1997 to the 2003. And also, sir acted as a president of this Indian Society of Theoretical and Applied Mechanics with headquarters at IIT Kharagpur for the year 2021. So here I mentioned very few about the Professor GRK sir achievements, and I take this opportunity after going through SAR profile, so one can easily make it out. So Professor G. Radhakrishnamacharya is a good academician and as well as a good administrator, and SAR inspired many students in his teaching career, and I am also one among them. Thank you, sir, and thank you for giving this opportunity.
Thank you, sir. Now, I would like to call upon the Dean, School of Physical Sciences, Dr. Deepak Samuel, sir, to felicitate the Vice Chancellor, Honorable Vice Chancellor of Central University of Karnataka, Professor Battu Satyanarayana, sir. Thank you so much for your presence here, sir. We are delighted to have you here. Thank you. Okay. So I feel profusely elated to hear the chief guest and keynote speaker of the program, Dr. G. Radhakrishnamacharya. Sir, I request you to address the gathering with your great words. Sir, over to you.
Yeah, good morning to all of you. Just a small clarification. Do I continue my keynote address or it is only for a few minutes now? Later the session will start. Can you please clarify?
Yes,
hello?
sir. The session starts later.
Yeah. No, I
Just,
speak only for a few minutes.
Okay.
Okay.
Yeah. All right.
Honorable Vice Chancellor, Central University of Karnataka, Kalaburagi, Professor Satyanarayana ji, Dean School of Physical Sciences, Dr. Deepak Samuel, coordinator of this coordinator Department of Mathematics and convener of this program, Dr. Srinivasulu, members of the faculty of Department of Mathematics, other faculty, participants from other institutions, my dear student friends, ladies and gentlemen, a very good morning to all of you. At the outset, I would like to thank the organizers of this program, in particular, Honorable Vice Chancellor, the Department of Mathematics, Dr. Srinivasulu, Dr. Janardhan Reddy, for giving me the opportunity to participate in the functions today and interact with all of you and share some of my views with all of you. I congratulate the Department of Mathematics for conceiving this particular program and organizing a two-day program on the eve of the birthday anniversary of Srinivasa Ramanujan, one of the greatest sons of India, the man who brought glory to our country by immense contributions. That the Srinivasa Ramanujan continues to be a source of inspiration to every one of us, in particular the young students. Who knows, there may be one Srinivasa Ramanujan among the students who are present today. I advise the young students to know more about Srinivasa Ramanujan, his works, and draw inspiration from him, so that you can also immensely contribute to the subject of mathematics and to the society in general. I will talk about Srinivasa Ramanujan later in my technical talk. I'll speak briefly about the importance of mathematics now for a few minutes. Mathematics is not merely a branch of science. Mathematics is a way of thinking. To be mathematical means to be logical, to be analytical, to be rational, and to be precise. In mathematics, when we say A by B, immediately we say B not equal to 0. When we say dy by dx, provided the derivative exists. When we say limit, provided the limit exists. When we say integral, provided the integral exists, and so on. Because we know under certain conditions only these things exist. So mathematics is subject of precision. Mathematics is subject of logical reasoning. That is why in most of the competitive examinations, whether it is banking examination or railway recruitment or preliminaries of civil services examinations, many of the entrance examinations, there will be aptitude questions which test your analytical capability, mathematical talent. The reason being, if somebody is good at mathematics, then he will be good at logic, he will be good at analytical reasoning. That's why mathematics is a way of thinking. Mathematics is a philosophy. Mathematics is an universal language. Mathematics is the language of nature. These are the words of famous scientist Galileo. Galileo told, if you want to understand mathematics, you need a language. That language is nothing but the language of mathematics. And in this language, the alphabets are straight lines, triangles, circles, squares, rectangles, ellipses, parabolas, and so on. Without the use of these alphabets and the language of mathematics, you can never understand nature. If you attempt to understand nature without the use of mathematics, you will be wandering in darkness. That is what he told. In fact, there are many examples to illustrate how mathematics is relevant in nature, how mathematics is considered as a language of nature. I will not go into the details now. Mathematics is the language of science and technology. Mathematics is the heart and soul of science and technology. But for the abstract and consistent findings of mathematics, many important discoveries would have eluded humanity. You name any important discovery in any branch of science, in any discipline of engineering, invariably mathematics would have been the basis for all such discoveries. Mathematics permeates all branches of science, all disciplines of engineering, all walks of life, and all spheres of activity. Another beautiful thing about mathematics is, in mathematics, every theorem has a story, every result has a history, every equation has a beauty, every concept has an application. I may not know the application for certain concepts. The mankind may not know the application for certain concepts. But if it is a properly coined, properly formulated mathematical concept, invariably it finds applications. In fact, there are many examples to illustrate this fact. There are many practical examples where mathematics plays a key role. And the history of mathematics is full of such examples. I will go into the details in my technical talk. I advise all the students, all the young students who are present here, who are attending this program, to take mathematics seriously. There may be students from mathematics, there may be students from other disciplines. I would only say that I don't advise every one of you to come to mathematics only. You may go to any branch you like. You may go to engineering. You may go to medicine. You may go to economics. But try to know the importance of mathematics in your branch. Whether it is engineering, whether it is medicine, whether it is economics, whether it is a language, everywhere mathematics has a role to play. A tree with weak roots cannot grow tall. If the roots are weak, today it may grow, then the growth will stop. If the roots are strong, even if it doesn't grow today, one day it will grow. And so is the case with mathematics. Students of engineering in particular, who are not strong in the concepts of mathematics, they cannot make deeper contributions in their later life. Students who are strong in the concepts of mathematics, even if they do not get good marks today, even if they do not get good grades today, when they enter their career, professional career, they will be able to make significant contributions. I want all the young students to know about the importance of mathematics and its relevance in your branch, whichever you want to pursue. Okay, I think I will give my technical talk, the contribution of Srinivas Ramanujam later. I thank the organizers for giving an opportunity to speak for a few minutes in this inaugural function. Thank you, and thank you so much.
Let me welcome you all to the International Seminar on Indian Mathematicians and the Contributions. Let me start off by thanking Professor Radhakrishna for his wonderful talk. I'm a physicist by training, and I know the use and impact of mathematics in physics. Physics cannot survive. For that matter, no science can survive without mathematics. But the way you put it elegantly, sir, I think I want to become a mathematician now after your nice talk. And in fact, I want to say a few words. I don't want to, since it's already late, I don't want to take much of time. I was in a conference last week, the Department of Atomic Energy, hosted by the Department of Atomic Energy. And I just made a statistical analysis of the nature of talks that were delivered there. And to my surprise, the submissions or the presentations from the theoretical physics side was overwhelming. It was much more than the experimental physics side. And the reason is very simple, because theory, first of all, of course, the funding is one aspect, but the other aspect is that for theory, you need a very strong foundations in mathematics. And Indian physicists, as they say, to be a good physicist, you should also be a good mathematician in the first place. And I think that's the reason why there was a lot of presentations from the theoretical physics side. So as is the ritual, now I would like to say, as a Dean of School of Physical Science, I would like to say a few words about the accomplishments of Department of Mathematics. So it started in the year 2000. I think I joined in the year 2000, very less. It started with Professor the manpower, lack of a job as proficiently as possible. And in 2016, they conducted innovative research techniques in mathematics that was also organized by Dr. Janardhan Reddy in 2017 onwards. So I think from 2017 onwards, like a ritual, they've been conducting the International Mathematics Day. During the COVID times, though there was a lot of problems, they still managed to conduct some interesting programs. In 2019, they conducted the international conference on current research in mathematical sciences. In 2020, they conducted a 3-day special lecture. And in 2021, an international conference on number theory and differential equations. And this is all possible only because of the dynamic leadership of the institution, both by the former Vice Chancellor, the current Vice Chancellor, and the able faculty members, both permanent and the contractual faculty members, and also the enthusiastic students. Yesterday, when I came at 7 o'clock, I was happy to see the department was in full glory. You know, the students actively participating and making posters, decorations, and all those stuff. You know, I sort of felt embarrassed because the physics department has yet to start its account in this regards. And so let me congratulate the Department of Mathematics for that initiative. Thank you very much for giving me this. Thank you.
Thank you so much, sir, for your words of appreciations. You have always been a pillar of great support and strength for the Department of Mathematics and School of Physical Sciences. So now I would like to request Dr. N. Sandeep to give the vote of thanks to the gathering.
Good morning to all. It is my privilege and honor to propose a vote of thanks on this occasion. So first and foremost, I would like to thank our Honorable Vice Chancellor, Professor Sachin, for gracing this occasion in spite of his busy schedule. So thank you very much, sir. Next, I would like to thank the chief guest of today's keynote speaker, Professor Radhakrishna sir, sparing his valuable time and motivate us by his inspirational and motivational words about mathematics. Thank you very much, sir, for accepting our invitation. Next, I would like to thank our registrar, Professor Basaras sir, and his absence here for his all administrative support. Next, I would like to thank our dynamic Dean Deepak Samuel sir for all his support. Is like backbone of all our programs in Department of Mathematics. So he's always supporting us morally, technically, in all the ways. So very much thankful to him, sir. Next, I would like to Dr. Srinivasulu Ballam sir, convener and coordinator of this program, who is the initiator of this program. Without him, it is not possible. So thank you very much, sir, for this initiation. And finally, I would like to thank all my colleagues, research scholars, and students, and all the participants for making this production a success. Thank you very much.
Thank you so much, sir. So I request all the participants to stay tuned as the keynote speech by Professor Shri G. Radhakrishna is beginning here. Over to you, sir. Oh, and meanwhile,
Hello.
sir, please proceed with your keynote speech. And meanwhile, we would like to felicitate the guest of honor, Dean School of Physical Sciences. Thank you.
Hello.
Yes, over to you, sir.
Okay.
Okay, sir, sorry for interrupting. The Dean of School of Physical Sciences for his presence here. I request Dr. B. Srinivasulu and Dr. G. Janardan Reddy and Sandeep to felicitate the Dean School of Physical Sciences. Thank you, sir. Sir, I request Professor G. Radhakrishnan sir to start with his keynote speech.
Okay.
Sir,
Yeah.
over to you.
How much time do I take? How much time do I have?
Thank you, sir. Huh? 11:10. It's just. So you can take 40 to 45 minutes.
Hello.
Hello, sir. 40 to 45 minutes will be okay.
I can go up to 11:10. Am I right?
Yeah. Yes, sir.
Around 40 minutes.
All right, sir.
Okay. Yeah, very good morning to all of you. First of all, I would like to know whether my voice is clear or not. Is my voice clear?
Yes, sir.
Okay. Yeah.
Yes, sir. You're audible.
Okay. I will start with my technical talk, in particular about Srinivasa Ramanujam and the contributions of Srinivasa Ramanujam. Right? I'll start with a small anecdote. Can I continue? Can I continue or do I wait for some time? Hello.
Sir, you can continue. Yes, sir, you can continue, sir.
Yeah. Okay. I will start with a small anecdote which continues to be a source of inspiration for young students. Once in a school, the teacher was explaining about the concept of division. As we all know that it is very difficult to understand division when you are in the elementary school. Addition, subtraction, those things you can understand, but division becomes difficult to explain also. Many times I wonder how the teachers can explain the concept of division to young students. So once the teacher was explaining the concept of division, the teacher told, if 50 sweets are distributed to 50 students, how many sweets each student will get? I repeat, if 50 sweets are distributed to 50 students, how many sweets each student will get? Immediately the students wrote 50 by 50. They cancelled and they said, teacher, every student will get one sweet. Then one student got up and asked, teacher, if no sweets are distributed to no students, how many sweets each student will get? I repeat the question. If no sweets are distributed to no students, how many sweets each student will get? All the remaining students, his classmates, they laughed at him. What is this stupid question? No students, no sweet. What is this? But the teacher was amazed. The teacher realized this is not an ordinary question, and the student is an extraordinarily brilliant student. And that student was none other than the great Srinivasa Ramanujam. We all know, we study this concept at +2 level, even at the graduate level. We call this 0 by 0. That is indeterminate forms, we call them. We call them indeterminate forms, and we resolve them using what is called L'Hospital's rule. What we study, only study at the graduate level, Srinivas Ramanujam could think of it when he was in the elementary school. That is the greatness of Srinivas Ramanujam. Srinivas Ramanujan, he was a genius, not merely a genius. He was a prodigy, not even a prodigy. He was a mystery. He was an enigma. He was what we call in Hindu mythology, Swayambhu, something like self-made. That is the greatness of Srinivas Ramanujam. He was born on 22nd December 1887 in Erode in Tamil Nadu. And during his childhood, he used to show extraordinarily brilliance. And most of the times, he used to solve the problem in the class even before the teacher could solve the problem. And he used to suggest even alternate solutions. Most of his seniors, they used to come and ask him for many doubts. We all know that in mathematics, the book of trigonometry, Loni's trigonometry, is a very standard book, right? Most of the problems which are, given, they are derived from the problems given in the Loni's trigonometry book. Very standard book, Loni's trigonometry. Very difficult to understand, very difficult to do the problems from that book. But Srinivas Ramanujan mastered that book at the age of 11. And nobody knew when mathematics became a sort of passion or obsession for him. But it seems there is a book called A Treatise of Simple Elementary Results in Pure and Applied Mathematics by Carr, C-A-R-R, Carr. There was a book published in 1886. Srinivas Ramanujam somehow came across that book. After he read that book, he could not think of anything else other than mathematics. And for him, every problem in that book was a research project. And consequently, as a result of his obsession or passion for mathematics, he failed in the examinations. And of course, he got married to Janaki. But one thing is, possibly, he's failing in mathematics and discontinuing the conventional education, possibly is a boon to the mankind, boon to the subject of mathematics, and possibly fortunate for Srinivas Ramanujan. Because had he continued his classes, his studies, he would have studied in the conventional mode, and possibly his brilliance would never have come to light. Because he discontinued, he got married to Janaki, and his financial problem started. And, there was so much of difficulty for him to make both the ends meet. At that time, somebody suggested to him, why don't you go and meet the president of Indian Mathematical Society? Indian Mathematical Society was formed at that time. One Mr. Ramchandran was the president. So Srinivas Ramanujan went to him to seek some financial assistance. When he walked into his room, Srinivas Ramanujan was never neatly dressed. He used to be very untidy and so on. When he came into the room, Ramchandran saw him and thought, what is this fellow? He is so untidy. Or is it really necessary to give financial help to this young boy to do research in mathematics? But after talking to him for a few minutes, the president of Indian Mathematical Society realized that this boy is an extraordinarily intelligent boy, and he should be given some financial support to continue his work in mathematics. Of course, later he also became a clerk in Madras Port, and he started working on mathematics, problems after problem, theorems after theorems. He started sending those to journals. His friends realized that the work he is doing is not ordinary work. It cannot be understood by cannot be understood by ordinary people. So they suggest to him, why don't you send this work to some eminent people in the world? Maybe they can give you proper guidance. Then he sent his work to few people. Other people did not bother. To his fortune and to the fortune of our country and to the fortune of the subject of mathematics, Professor Hardy, Cambridge University, who received his letter from Srinivas Ramanujam, he outlined the work which he has done. Then he had just glanced through those papers and he thought this is all nonsense. It doesn't seem to make much sense. He simply threw away those papers. But he went to the university, something was nagging him. Maybe there is something great about that work. Possibly I did not pay much attention. Let me again go through that work. Then he called his friend, another eminent mathematician by name Professor Littlewood. He said, Professor Littlewood, why don't you come to my house? Both of them came to Hardy's house in the evening, and over a cup of coffee, they carefully shuffled through the papers sent by Srinivas Ramanujam, and they realized this work is something extraordinary. And the person who worked on these problems, he is not an ordinary fellow. He is something like a genius actually. Then they decided to send an invitation to Srinivas Ramanujam to come to England. And of course, they sent an invitation. But as we all know, Srinivas Ramanujam comes from a Orthodox Brahmin family. So his mother says, you cannot go. If you go to England, we will not be able to follow our traditions. But later, the divine design, somehow he got the opportunity to went to England, and he sailed to England in 1914. There he started working in the company of Hardy. One great thing about Srinivas Ramanujam is his originality, creativity. Everything he did was original. Not that Srinivas Ramanujam did not commit mistakes. He used to commit lots of mistakes, but they were also original in nature. And in fact, Srinivas Ramanujam was very unconventional in giving the proofs. In mathematics, suppose we have to prove a theorem, we say what is the hypothesis, what is to be proved, how it is to be done. Step by step, we give a proof. But Srinivas Ramanujam was very unconventional. Many times he used to write the proof is very simple, very trivial. So Hardy decided to put him in the conventional track. So he told Srinivas Ramanujam, it is not like this. You please do follow this particular approach. But after some time, he realized by putting him in the conventional mode, his originality is getting killed. So he thought, let me leave this fellow to himself. Let him do as he likes. Because once I put him in the conventional form, maybe his originality is losing his originality. So Srinivas Ramanujam started working in the company of Professor Hardy, and he started, producing theorem after theorem, results after results, so many results. And finally, of course, he became sick in the year 1919. He came back to India, and in the year 1920, he died. Srinivas Ramanujam, as I told, after he read that Carr's book, he constructed so many results which were available from 1812 to his time. Not that all the works he gave were original. Some of them are already available. But Srinivas Ramanujam, without knowledge of those results, he derived them independently. He derived on so many, his contributions are so many areas, like elliptic functions, Riemann zeta functions, calculus, algebra, geometry, hypergeometric series, convergence, so many areas. And they find applications in, of course, apart from mathematics, physics, in what we call cryptography, probability and statistics, right? Holography, acoustics, signal processing. Some of his results, they find applications even in areas like string theory. String theory is a very latest topic. Of course, one thing is, there is one particular contribution of Srinivas Ramanujam which needs to be specifically mentioned. Scribbled in black ink, 130 pages, unlabeled pages, containing mystified mathematical equations, which make no sense at the first glance. They were collecting proverbial dust kept in a box in the corner of the library of Trinity College, for over 50 years, 50 years, until accidentally chanced upon by one Professor George Andrews from Pennsylvania University one fine morning in 1976. How Professor George Andrews came there, that is a very interesting story. I will not go into the details. And Trinity College itself is a very great college. I think many of you must be knowing. It is a constituent college of Cambridge University. 34 faculty members from Trinity College, they got Nobel Prize. 5 faculty from Trinity College got field medal. The alumni of Trinity College include 6 British prime ministers. That is the greatness about Trinity College. So in the Trinity College library, in a box were lying 130 pages written in black ink, until Professor John Andrews accidentally came across those papers one fine morning in 1976. Once rediscovered, these mathematical pages electrified the whole world of mathematics. Famous physicist Freeman Dyson, he remarked, these are the flowers that grew from the seeds that ripened in the garden of Srinivasa Ramanujan. These inequalities, called Mach theta functions, MOCK Mach theta functions by Srinivasa Ramanujan, were written by him few days before he passed away in 1920. Even 100 years later, today, these esoteric and abstruse mathematical equations continue to tantalize the mathematicians around the world. Mathematicians explore how to use these Mach theta functions to make the internet secure. Physicists use these Mach theta functions to comprehend the incomprehensible black holes, and also to understand how do the fundamental particles interact with each other. Mathematicians all over the world, they were all startled, they were all amazed how this mathematician who studied in a small town in southern part of India and who failed in an examination and who died of a mysterious disease at the age of 32 could make such a remarkable discovery which eluded the most brilliant minds of the world for centuries. That is the greatness of Srinivasa Ramanujan, right? If you, as I told already about his contributions, if you go to Madras Central Library, there are 3 books are there. The first book contains Riemann zeta functions, all his contributions, he would take a long notebooks and he would write in those books. Riemann zeta functions and magic squares, the first book. Magic squares we see everywhere, but the magic squares given by Srinivasa Ramanujan, they are extraordinarily magic squares. Second book contained continued fractions. He did extensive work in continued fractions. Continued fractions, the students of mathematics know, is a very important concept. Third book, there are many blank pages. After that, there are a few pages which contain gems of results about mathematics, especially related to pi. Those days, more than 100 years ago, when there were no computers available, no proper calculators available, how he could get the values of some of the things to several decimal places is something which is really a mystery. And as I told, that particular papers which were lying in a Trinity College, that is known as the last book, LOST, last book, because that was untraced. After his death, that was sent to Hardy and it was lying in the Trinity College till later it was brought to light. And now, after that book came to light, people started understanding the impact of the work of Srinivasa Ramanujan. As I told, whether he knew about the applications of the concepts and theorems he gave, but today people realize that most of the works, or almost all the works of Srinivasa Ramanujan, they find applications in diverse areas, not one subject, as I mentioned, diverse areas. signal processing, string theory, black holes, internet security, whatnot. Internet security is something which was unknown at that time. But the Mach theta functions given by him, they find applications even in such diverse areas. And, he was ultimately given doctorate. He was made what we call Fellow of the Royal Society of London, Fellow of Cambridge Philosophical Society, Fellow of Trinity College. These are great honors, not ordinary things. To become a Fellow of Royal Society of London is something a great honor. And ultimately he became sick and he returned to India. When he returned to India, there was a rousing reception for him. But then for 1 year, he was on sick bed. Then of course he died in 1920. Unfortunately, people from his community, they were reluctant to perform the final rites for him because they said this fellow broke all the traditions by traveling abroad. Later, of course, they were prevailed upon and they performed the final rites. And as you know, during that last 1 year, 1919 to 1920, when he was on the deathbed, he worked on these important, very complex functions, Mach theta functions. Normally, people, when they become sick, they start worrying about their family, about their property, about their children, wife, and so on. But Srinivasa Ramanujan worked on a very, very complicated mathematical concept called Mach theta functions, which people were unaware for decades together. That is the greatness of Srinivasa Ramanujan. In fact, Hardy was asked to rate mathematicians. How would you rate mathematicians? Then Hardy told, on a scale of 0 to 100, to himself, he gave 25 marks out of 100. Littlewood, another famous mathematician from Cambridge University, he gave him 30 marks, 30. And he gave Hilbert. Hilbert is considered as one of the greatest mathematicians of all times. To him, he gave 80 marks, 80. And to Srinivasa Ramanujan, he gave 100 marks. That is the greatness of Srinivasa Ramanujan. And somebody asked Hardy, what is your greatest discovery? Hardy said, my greatest discovery is the discovery of Srinivasa Ramanujan. Okay, that speaks volumes about the greatness of Srinivasa Ramanujan. And one more thing is, we should all be grateful to Professor Hardy. But for Hardy, nobody would have known about Srinivasa Ramanujan. And normally, in the professional circles, one feels jealous of the other. These days, somebody, when you send a paper for publication, somebody try to use that paper. But Hardy and his colleagues, they tried to bring Srinivasa Ramanujan to London, make him work and make him popular. The whole world could know about Srinivasa Ramanujan in our country. Till Srinivasa Ramanujan came on the scene, though there were significant contributions from Indian mathematicians during ancient times, like Aryabhatta, Bhaskaracharya, so many people, but they were not properly documented, they were not patented. But Srinivasa works, because they were done in England, in the Cambridge University, it was known to the whole world. The whole world was really taken aback by the works of Srinivasa Ramanujan. In fact, I'll show some of the works. The time is now 10:50. I have another 15 minutes time. Last maybe 10 minutes, I'll show some of the slides, some of the works of Srinivasa Ramanujan. Before that, I want, as I told in my inaugural address, about the importance of mathematics. As I told, every concept in mathematics has an application. But most of the times, many of the concepts, when they were given by mathematicians, the applications were not known for quite some time. Applications may be known at a later time. I'll give few examples of that. One is the example of conic sections, which every one of you would have studied, all the students. The concept of conic sections were given by Grecian mathematicians 2000 years ago. They were very fond of geometry I will not go into the historical details here. Using the definition of conic sections and the Aristotelian logic, the Grecian mathematicians systematically derived all the properties of conic sections. 16 centuries later, the famous, astronomer Kepler, after painstaking study of the sky, came up with 3 laws of planetary motion. One law says every planet traverses an elliptic orbit with the sun at the focus. He uses the properties given by the Grecian mathematicians. Few decades later, the famous British physicist and mathematician Newton derived this particular case of all-encompassing universal law of gravitation. In this satellite age, the importance of conic sections need not be overemphasized. You know that we all study at the graduate level. The path of a projectile is a parabola, which is a conic section. So in the launch of satellites, satellite motions, the properties of conic sections are extensively used. A mathematician may not go and sit in the satellite center, but the formulae given by the subject of mathematics and the mathematicians, they are used in the launch of all these satellites. Also, to predict the eclipses and to know the position of planets at different times, the formulae given by Grecian mathematicians about the conic sections are being used. And another important thing, today we talk of energy crisis. So what is that we do? We talk of solar energy everywhere. What is that we do in solar energy? On the rooftop, we put solar panels. The panels, they try to absorb the solar energy and of course convert it to some other form. Now people realize instead of a flat panel, if you have a parabolic panel, a solar panel in the form of a parabola, there is more concentration of solar energy at the focus of that parabola. So more energy can be harnessed. So you see, the concepts given 2000 years ago are being used in diverse areas. Why? We all go by car, automobile. Automobile, we have a headlight. What is headlight? It is an example of the application of conic sections in the form of a parabola. So this is one concept which were given thousands of years ago, but today we find it finds applications in several areas. Another example is example of binary numbers, binary system. We all know binary system. Who gave that? Let us not go into the controversy. Indians say we have given it, others say we have given it. Let us not bother about it. What is binary system? Normally we represent a number using 0 to 9, right? Units place, tens place, hundreds, and so on, so on. But somebody thought, why not we represent a number using 0 and 1 instead of 0 to 9, right? And we all know, I'm sure all of you would have studied at the 7th class or 8th class, how to represent a number in binary system. It is a very tedious process, a torturous process. If you take a number, if you want to represent the binary system, it is a string of characters, a long string of characters, zeros and ones. So it was thought it is only out of intellectual curiosity of mathematicians this is given, and it is not useful in any way. But today we realize in the computer age, computer knows only one thing. Whatever language is used, whatever platform is used, it knows only one thing. Circuit is on, circuit is off. That is 1 and 0. So this is where the binary system comes into picture. And today, without computer, there is no life. Every walk of life, every sphere of activity, we have only computer. And then computer, the basic thing requirement is the binary system, a concept given by students of mathematics. One more example is, we all know Newton was trying to study the concept of particle motion, right? Using what are called fluxions. And when he tried to study particle motion, means suppose a particle is given with a velocity, initial velocity, where it would be after some time. Suppose if it reaches so and so time, what was the velocity or speed of that particular body or object or particle, whatever you may call. Ultimately, when he derived the particle motion, he derived not only he could, discuss particle motion, but he also came up with what is known as calculus, right? Rather the concept of limit. The concept of limit is known as the greatest creation of human mind, because without limit, there is no continuity. Without limit, there is no differentiability. Without limit, there is no differential equation. Without limit, there is no integral. Without limit, there is no convergence. Without continuity, without differentiability, without differential equation, without integral, without convergence, can we think of anything in any branch of science or discipline of engineering? You see, in all engineering problems, scientific problems, we are concerned with the rate of change of linear momentum, rate of change of angular momentum, rate of change of energy, rate of change of enthalpy, rate of change of profit, rate of change of population. And today, in the context of COVID, epidemiology has gained a lot of importance. How does the epidemic grows? All these cases, rate of change. Wherever you talk of rate of change, the derivative comes into picture. A differential equation comes into picture. So you see the concept given by the concept given by Newton to understand the motion of a particle became a great boon for the mankind. And from calculus, we got mathematical analysis and so many things. And one more example is Michelson Morley conducted an experiment to study the motion of air through ether. There were some inconsistencies, and Einstein was trying to explain those inconsistencies. Ultimately, he came up with theory of relativity. Then he got E is equal to mc square as a corollary, and E equal to mc square ushered in the atomic age. So you see how mathematical concepts lead to new subjects, new applications, new areas. Why? You take, for example, all of us, we use mobile. Today, there is nobody who doesn't use a mobile. In mobile, we have what is called an antenna. You are able to see, you are able to speak to somebody who is abroad. I speak to my daughter who is in USA every day, morning and evening, through this mobile. How I am able to do it? It is through the antenna. And the antenna's design depends upon a mathematical concept called fractal. The fractal, very loosely speaking, is a fractional dimensional entity, or an entity which is infinitely divisible and self-similar. In fact, NIT Warangal, the EC department, one professor, the students were working continuously on design of new antennas, and they all had taken one course, fractal geometry, and I used to set the question paper and help them in that particular subject. So the fractal geometry, the basic concept is what we study in mathematical analysis, what we call Cantor set. We study in mathematical analysis at the graduate level, 0-1 closed set, which we call Cantor set. Then we divide into something and divide. Ultimately, we get what is called a Cantor dust. So it is based on this concept, the so-called fractals are developed. And IFS, iterated function system, the concept of fractal was given by Mandelbrot in the year 1982, right? It is a generalization of classical geometry. All the shapes in the nature, they are irregular. For example, if you take the edge of a mountain, edge of a cloud, the feather of a bird, you take the, for example, map of India, the continent, all these are irregular in shape. How to measure them? That is where this comes. So today, the concept of fractal given by mathematicians, they find applications in signal processing, design of antennas, in geophysics, biomedical technology, study of ECGs and so on. That is how mathematics influences different fields. Another thing is, we all send, when we send mails and we send WhatsApp messages, we send JPEG images. These JPEG images, they're all based on what is called wavelets in electronics. In mathematics, we study, I think of the BTech students, graduate students, they study what is known as Fourier series. Generalization of Fourier series, when it becomes adequate in particular situations, it leads to the concept of wavelets. And wavelets are extensively used in signal processing, biomedical technology, fluid dynamics, and so on. For example, when a plane takes off, when the plane lands, there will be vortices, eddies, very critical situation when the plane is taking off and when it is landing. There, the concept of wavelets are used to analyze that particular situation. And this wavelet, people used to think functional analysis, mathematical analysis is the fancy toy of a pure mathematician. It doesn't have any applications. Now people realize in order to understand and develop the so-called wavelets, which find applications diverse areas, the subject you need is functional analysis, a pure mathematics subject. That is how the beauty of mathematics comes into picture. Similarly, there is what is called another concept called fuzzy. I don't know how many of you know about fuzzy. Fuzzy concept has become very important today. For example, you take a washing machine. Suppose you have a fan. You have 0, 1, 2, 3, 4, 5 speeds. In between 3 and 4, if you want, you don't have an option. Now the concept of fuzzy has changed the situation. In a washing machine, they use fuzzy concept. Depending on the dirt in the cloth, it adjusts the speed. The sensor sees how much dirt is there. Accordingly, it adjusts the speed. There use the concept of fuzzy. In Karnataka, there was a the farmers wanted water to be released from a particular dam, and if they release the entire water, there is no water for electricity generation. And if you don't release the water, the crops would wither away. What is to be done? They gave the problem to ISIMC Bangalore Civil Engineering Department using the concepts of fuzzy. They came up with a solution and helped the government of Karnataka in taking appropriate decision. Today, we talk of artificial intelligence everywhere. What is artificial intelligence? Nothing but the basic things you need are linear algebra, statistics, and a little bit of computer programming. Of course, later you need to use several advanced techniques. You go everywhere today, we talk of artificial intelligence only. You go to SBI, Yono app, you only need one. It uses artificial intelligence. Everywhere you use artificial intelligence. Today we talk of big data, data analytics. Everywhere you have large data. If you can't analyze the data, if you can't make out anything from the data, it is as good as it is not having anything. In order to do that, you need the concepts of statistics. The concepts, in fact, when I was at NIT Warangal, the old students, when they come for Silver Jubilee reunion, they come and told me, sir, today there is a lot of scope for students who are good in the fundamental concepts of mathematics, in particular linear algebra, and who are good in statistics. For them, sky is the opportunity. If you know anybody who is good in these things, please tell me. So that is how the importance of mathematics is being known. Earlier, people used to think there is nothing common between medical stream and engineering stream. That is different, this is different. But today, people realize that each can contribute to the other. Engineering, in particular mathematics, can contribute to the understanding of biological systems, and biological systems can give innovative system to the engineering domain. Today we have biotechnology, bioinformatics. IITs are starting medical programs. ISC Bangalore, they have integrated program, MBBS together with the MTech. That is how knowledge is coming together, and the importance of mathematics is being known. As I told in my inaugural address, a tree with weak roots cannot grow tall. One of my friend at NIT Warangal, he studied MBBS from Jipmer Pondicherry. When he completed MBBS and came, my colleague called me and told me, Radhakrishna, my son wants to talk to you. He came and asked me, uncle, please teach me abstract algebra. I told him, you are a student of medicine. Why do you need abstract algebra? No, uncle, in genetic theory, we need abstract algebra, groups, rings, and so on. So that is how mathematics helps even in understanding the biological systems. I think I have only 5 minutes left. Maybe I think I will try to share some of the few works of Srinivasa Ramanujam. Okay, let me see if, I'll quickly run through them because these are all Aryabhatta, Brahmagupta, Bhaskaracharya, Srinivasa Ramanujam, then P.C. Mahalanobis, C.R. Rao, Kaprekar, recreational mathematician, Satyendranath Bose, Manjul Bhargava recently, a very young man who got field medal in the year 2014. He worked on a number theory, geometry of numbers. Another young person is Akshay Venkatesh. He got field medal in the year 2018. Field medal is known as the equivalent of Nobel Prize for mathematics. So it is a matter of pride that these two young people, Manjul Bhargava is a part of the new educational policy drafting committee, and Akshay Venkatesh, right? Now I'll give some of the contributions. I'll take quickly 5 minutes and wind up. Ramanujam, I remember once going to see him when he was ill at Putney. I had written in a taxi cab number 1729. He remarked that the number seemed to be rather a dull one, and I hoped it was not an unfavorable woman. No, he replied, it is a very interesting number. It is the smallest number expressible as sum of two cubes in two different ways. You see, Hardy went to see Ramanujam when he was lying in the hospital. Then he casually told, I came by a taxi, number of the taxi 1729. It seems to be a dull one. Srinivasa Ramanujam, who was on the sick bed, immediately shot back. He said, no, it is a very interesting number. You see, 1729, 10 cubed plus 9 cubed, or it is 1 cubed plus 12 cubed. So it is the smallest number which can be expressed as sum of two different cubes. And 1729 is divisible by the sum of its digits. It is the Harshad number. So you take 1 plus 7, 8, 8 plus 2, 10, 10 plus 9, 19, 19 divides 1729. Then 1729 is one of the four positive integers, which when its digits are added together, produces sum, which when multiplied its reversal, it's the original number. You take 1 plus 7, 8, plus 2, 10, plus 9, 19, right? I'm sorry, there is a small mistake here. This 19, you reverse it, you get 91. 19 into 91 is 1729. Similarly, if you take 1458, 4 plus 1, 5, 5 plus 5, 10, 10 plus 8, 18. 18, you reverse it, you get 81. 81 into 18 is 1458. Similarly, 81, 8 plus 1 is 9. You reverse, you get 9. 9 into 9 is 81. It is also a product of 3 primes. 1729 is equal to 7 into 13 into 19. Then nested radicals, this is one area where he did lot of work. He posed a problem in the journal. Square root of 1 plus 2 into square root of 1 plus 3 into square root of 1 plus so on. He waited for a solution to be offered, but failed to receive any money. At the end, Ramanujan supplied a solution to the problem himself. He gave the answer, of course. You see, for example, answer is 3. You can easily see the working here. 3 is root 9, 1 plus 8, 1 plus 2 into root 16, and so and so. So he gave the answer. Nested radicals is one area where he gave a lot of, made significant contributions. Composite number, you consider number 220. It has 12 divisors. What are they? 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, 110, and 220. There are 12 divisors are there. Out of 12 divisors, there are 3 prime divisors. What are they? 2, 5, and 11. Now, if you see, 220 is equal to 2 square into 5 into 11. So here 2, 5, and 11 are prime divisors. So what is the relation between the number of divisors D and the prime divisors K? How are D and K connected? Here D is equal to, you see here, this is 2 divisor, 2 plus 1, divisor, 1 plus 1, divisor, 1 plus 1, that makes it 12. So D is equal to, so if you generalize this, suppose if you write a number n is equal to P power A1, P2 power A2, Pk power Ak. For example, here P1 is 2, P2 is 5, Pk is 11, and A1 is 2, A2 is 1, Ak is 1. Then what is the relation here? You see D is equal to 1 plus A1 plus into 1 plus A2, 1 plus Ak. So he got a relation between the prime divisors and divisors of a composite number. I am giving only a very elementary results because it is very difficult to understand all those things. Then partitions. If you take a number and represent the sum of positive integers, for example, P0, you can represent 0. 1 you can represent as 1. If you take 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, 1 plus 1 plus 1. So here the order doesn't matter. 5, P5, 5, 4 plus 1, 3 plus 2, and so on. So what is the important thing about here? I will share it later. Okay, right. Okay. Yeah. So from this, he got what are called Roger Ramanujam identities. So we know this is P of 5 plus 4. This is, we know this relation, congruent modular relation. If you take n is equal to 0, for example, if you take n equal to 0, you get a P4. What is P4 here? You see here, P4 is, how much is P4? P4, 5. So 5 is divisible by 5. Then, for example, n equal to 0, P5. What is P5? You see above, P5 is 7. 7 is divisible by 7. The, what you call the remainder is 0. And P6 is 11. So congruent module 11. So these identities Ramanujam got, but in order to derive these identities, you need very complicated mathematics. I will not go into the details of them. I'll end with the last one example. You know, Mahalanobis, as I told, himself is a very eminent mathematician. One day, he posed a small problem to Ramanujam. He said, Ramanujam, there is a street in which there are a row of houses. You make them, mark them 1, 2, 3, n. Suppose you take a house in between x. You see the sum of the numbers of houses to the left of x should be the sum of the numbers of the houses to the right of x. What are the values of n and x? He thought it is a very difficult question. Ramanujam would struggle. But Ramanujam, within a minute, he gave solution. Not only he gave solution, he gave a class of solutions. For example, you take trivial case, you leave 1. N equal to 8, x equal to 6. 1, 2, 3, 4, 5, 15. After 6, 7 plus 8, 15. You take n is equal to 49, x equal to 35. 1 plus 2 plus 34, you get 595. After 35, 36 plus 37 up to 49, you get 595. So this is another example, you know. Then they asked, how did you solve it? He said, I have solved it using what are known as continued fractions. There are a number of, quotes about Srinivas Ramanujam. So I think I will skip all of them because I have taken my time. Thank you so much for your patient listening. I presented only very elementary mathematics so the students can understand. I did not go into the complicated mathematics. In fact, even for me also they are difficult. So I'm sure all the young students who are present here would draw inspiration from the life story, life sketch, and the work of Srinivas Ramanujam, and continue to know the importance of mathematics in whatever domain you are. As I told in the morning in my inaugural address, I don't want everyone to come to mathematics only, but try to know the importance of mathematics in your domain, in your subject. Maybe it is engineering, maybe it is physics, maybe it is chemistry, maybe it is economics, maybe it is a language, maybe it is medicine. Okay, you will be able to make wonderful contributions if you are strong in the fundamental concepts of mathematics. Thank you. I thank the organizers for giving me an opportunity to share some of my views with all of you. Thank you. Thank you so much. Yeah, is there anything?
It is my second hour, sir. Yes. Sir, I'm audible, sir?
Yeah.
Yeah, sir, thank you, sir, for your excellent and motivated talk. And really, sir, I also carefully, I also followed your talk, but it was very, very nice and excellent. And definitely, certainly, all the participants and our MS certainly they benefited from your talk, and I'm sure definitely they will get motivated, and definitely they will follow your words. And sorry for the inconvenience, sir. Actually, we tried a lot to bring you for offline session here, but unfortunately, due to technical problems, it couldn't happen. Sorry for inconvenience.
It's okay. It's okay. Okay. Hello. 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 Okay, thank you. I just wanted to say one thing, but I think there is an interruption. 1 minute. Hello. Can you hear me? Hello. Can you hear me?
Just a moment. Yes, sir, over to you.
Yeah, I thank you once again, all the organizers. Only one thing is, I wish, as Dr. Janardhan Reddy told, it would have been offline. I get more enthusiasm. I feel young when I see the face of young students that I really miss here when I give an online talk. Anyway, because of the constraints, possibly you had to arrange online. Right? Thank you so much. I wish you all good luck. Thank you. Can I leave now? Yeah, I think a lot of interruption. Okay, right. Bye.
Am I audible? Please let me know whether am I audible. Triangle, Professor University University, Turkey. Sir is going to give a speech on mathematical thinking. What would I introduce now? It is a very long one. I will try to brief it as much as I can. So, Professor Ismail Triangle is son to a post office officer and a homemaker. He born in August 1967, and after his primary and higher school education, he started his first MSc in 1987 and became a research assistant in 1988 in Uludağ University Faculty of Arts and Sciences. After completing MSc in 1989, he also did his second MSc from USA in mathematics itself, and then he did his PhD in 1994 on the subject normal subgroup of Hecke groups. After completing the compulsory military of 16 months, he joined as assistant professor in Uludağ University in 1995. He became a full professor in sciences and also research services. Sir has written over 49 books on mathematics, and he has written 640 scientific papers which have indexed in
Style and WS database. Also, he has supervised 30 projects. His international collaborations are more than 10. Some of them are India, France, UK, USA. Member, highest number of annual project prize, Scientist of the Year in 2012, and this list continues. So now I would like to invite Professor Ismail Naji Sandel to give a talk on mathematical thinking. Sir, over to you.
Thank you. Can you hear me clearly? Good, because I cannot completely hear you because of the microphone or whatsoever. But the important thing is you hear me because I am talking. So hello to everyone. I'm so excited to be in Central University of Karnataka after a few weeks. Because a few weeks ago I was there physically to meet my friends, Reddy, Ranganatha, Sandeep, and others. So I am again excited to see them and hope to see many more times. Good, okay. So this is a special day for Indian mathematicians because of the birthday of Professor Ramanujan. He is greatest guy in mathematics history for all of us, not only for Indian mathematicians, for all of us. So I'm normally not giving any talks about Indian mathematicians regularly, but this time, because of this occasion, special occasion, I'm asked to give a talk in about Indian mathematics and their contribution, the Indian mathematicians' contributions. Of course, the number of these contributions are endless. I cannot talk in 20 minutes, in 30 minutes, in 1 hour, in 2 hours, in 2 days about Indian mathematicians. Probably I will be talking about some of the Indian mathematicians and in general the contributions of Indian culture to world culture today. I'm teaching regularly history of mathematics in my classes here in my university, and some of the courses, some of the hours that I teach in the history of mathematics belongs to Indian mathematicians. So I'm not reluctant to Indian mathematics, but I am not an expert in history of mathematicians, of course, history of mathematics, but I will be trying to give my ideas and you will understand what is Indian mathematics looking from another point, from Turkey. So, thank you again for the invitation to International Seminar on Indian Mathematicians and their contributions on National Mathematics Day for India. So again, I'm happy to be invited and to be talking to my friends and especially to young students. So, I assume you see my screen. So I'm from Bursa Uludağ University in Turkey. So I congratulate this special day for all Indian mathematicians as well. Let's start. So as far as I know, the history of mathematics started with Indian and Chinese mathematicians, okay, in the same times approximately, because modern era for humanity started not from USA. USA was not there, okay, or Europe was not there. Only Asia, Asian culture, Asian countries, especially India and China, was there at the beginning. You know, many rules, many methods in mathematics, in number theory, in algebra, in applied mathematics, in numbers, in geometry, are due to Indian or Chinese mathematicians. Actually, every country writes their history. Historians usually write history according to their wishes. They don't like to write the disadvantages to their culture, to their country, to their nation. They usually make small changes. We call them white lies. And they explain history in the way they like it, okay? Sometimes this means history is sometimes lying, okay? Historians may be lying because of they want to give the things, the notions, the events according to their wishes. This is happening, unfortunately. This is not mathematics. Mathematics is unchangeable. No one can do to anything, to any harm, any damage to mathematics. No one can change any proof. If it is proven already, there is no other way. No one can change it. Only someone can give another proof. If something is proven, it is there forever. But in history especially, everything is unreliable, unfortunately. You have to look at the writer of the book, History of Mathematics book first, and you will guess what he is writing there. It's like politics, unfortunately. Okay, my friends, after the beginning, this the hegemonia moved to Egypt, Anatolia, and ancient Rome. This part, today we call Far East mostly, was for a long time, the center of culture over the world. Then Arabs, Arabic countries, old Greeks, Italians. Of course, there are some other small countries which do not exist today, some especially the ones with strong navy, okay? They went to everywhere to get more and more out of the places they visit. So these countries existed around the Mediterranean Sea. So Turkish mathematicians also followed this trend. So later on, all the Mediterranean Sea, you know, this is the Mediterranean Sea, this in the circle. Turkey is here, the brownish one. And these are Italy, Greece, Bulgaria, Portugal, Spain, Lebanon, Egypt. These countries are all around Mediterranean Sea. So these countries, after some time, were very strong culturally and of course scientifically. Because of the navies and trade around the Mediterranean Sea, people were going to other countries, visiting their scientists, meeting their scientists, mathematicians, getting their information, getting their handwritings, getting their books, getting their theorems back to their countries. So when they go back to their countries, they taught all what they got from these countries. So at that time, around the Mediterranean Sea, the culture was very strong. The mathematics was very strong, especially like Diophantine equations. Many types of equations were studied on this region. So at the beginning, Indian and Chinese, mostly Indian culture, was very effective. So all other cultures are affected from Indian culture. Actually, there are many examples I can give about this to prove this as a mathematician, but especially for my young friends, I want to give an example that I like most. I visited India about 10 times, maybe more, I don't know now, in the last 17 years. The last one being last month, and the previous one being just before the pandemic, COVID-19. So I regularly come and visit India. Once my friend, Professor Chandrasekhar Adiga from Mysore University, he's now retired, but he's still actively working, took me to Mysore Palace. Probably some of you have been there. It's a great palace, very wonderful, especially when they are lighting it in the special days. It is wonderful. You must see it if you haven't. So in Mysore Palace, there are some secret rooms. And when we visited, I was very surprised to see something I will explain now. Then you will get the power of Indian culture. I always respect Indian culture. So when you are inside, you don't see the power, you don't feel it too much. But from outside, you see it and you understand it better. Like your child, your children, when they grow up, you don't see, because every day, every hour, you see them. And gradually they are growing up, but you don't realize that they are growing. But someone else, some aunt, some uncle, or some neighbor who hasn't seen them for 1 year, they come and see them, and oh, they say, how big you are, how grown up you are now. Okay, this is like this. You may not realize, especially my young friends, may not realize how strong Indian culture, Indian mathematics is, and very effective, how effective it is. So in Turkey, there is this thing, maybe you will understand what it is. It is shadow theater. In Turkey, everybody thinks that it's a Turkish invention. And in the last 600, 700 years, it was around, okay? So its history for Turkey goes back to 600, 700 years ago. It is shadow, it's like this. Some guy pulls these puppets, okay? Leather puppets, some characters, figures, men or women, sometimes children. They move them, and they always argue, they talk, they tell funny things, okay? This is shadow theater as a Turkish invention. If you say to a Turkish guy that it is not Turkish, it is Indian or it is something else, they will strongly disagree with you because it is so identified with Turkey, okay? These characters, we call them Karagöz and Hacivat, okay? Their name in Turkish. So it was around Turkey, Greece, in Balkan countries, it is so famous, this shadow play, okay? So when I come to Mysore, in this hidden room, secret room in the palace, Mysore Palace, we have seen some figures like this, one meter long, 1 meter in the length, okay? 1 meter tall characters like this. and they were from 2000 years ago. They were dated 2000 years ago. So you see what I mean? We have this, and it goes back to 600 years ago, but your culture have already had it 2000 years ago. So it seems that we've got it somehow from India. There are many examples I can tell you, but no time to talk all of them. For example, in the Orissa region, this is Ravana Chaya. For example, in Kerala, these figures are called Tol Pavakutu. This kind of shadow theaters are there. I don't know how active they are, but in Turkey, there are still sometimes on the television, some historical days, they show it, especially children like it, of course, it's puppet show. So this shows that you started many things, you exported them, you shared them with other countries, other nations, humanity, and the starting point for many things is India. So all young friends must be very proud of India and being Indian. And they must work harder because of their responsibility. They belong to a big nation, one of the greatest nations all over the world for all times. I feel like India is my second country, so I feel more affected about this, what I'm saying, okay? So, I will be talking as the title of the talk, mathematicians. And I will give some examples and some contributions as far as I teach to my students. And the first one is a famous mathematician and astronomer, actually. He called Aryabhata. He lived in 476 till 550. For a mathematician, this is a long time, 74 years. For example, Srinivasa Ramanujan lived 33 years. Some mathematicians like Galois lived only 21 years. Sometimes I think that God knows better, because these guys, if they lived 80 years, 90 years, okay, probably they would solve everything. And we would be hungry as mathematicians because there would be nothing left to solve, to prove. Because in 10 years, 13 years, sometimes 2-3 years, because they lived only 18, 20 years, 30 years, that means except the childhood, they worked 2 years, 5 years, 10 years in mathematics, and they established great theories. You know, Ramanujan lost notebooks. Still, people are trying to understand for decades. So great work, so important work, so difficult to understand work, okay? So Aryabhata, of course, is the traditional figure in Indian mathematics and astronomy. This kind of visionary mathematicians are called in history as mathematicians of vision. And modern astrophysics and mathematics have their roots back to the research and writings linked with them, okay? This kind of guys, Aryabhata and the others. And these guys, these professors, these mathematicians were always ahead of their time, sometimes decades ahead, sometimes centuries ahead, because what they found, what they gave, what they proved was active in another country many decades later. They found the same results many decades later, after Aryabhata, after the others. This Aryabhata was born, according to many theories, in Ashmaka in 475 or 76. Actually, we get this date from some problems he gave about his, he sold in 23rd years of his life. So we subtract the years and we found it 475, 76, because this is 15 centuries ago. There is no reliable documents except the people's writings, okay? There was no multiplication, making multiple copies, this kind of Xerox copies, photocopies, okay? So it was difficult to keep the information secure. So many information, many books, many handwritings have been lost, unfortunately, from these times. If maybe we have them, we would have more idea about the history, what they have done, and who has done what, okay? Of course, his important studies have taken place in Kusumapura, and probably he lived in this region, and in fact in Pataliputra as well, because there was an observatory, astronomical observatory, and there was not many astronomers. So probably people say that Aryabhata lived in Pataliputra for a long time, for example, okay? Consequently, he spent a lot of time here as the master astronomer. So he lived there. He has done astronomical calculations, and to do this, like everyone, every scientist, he needed mathematics. So he was good in mathematics. At that time, there was no title as mathematician, as physician, as chemist, as historian. There was philosophers, thinkers, these important people, and they did everything. They studied everything. They studied music, they studied physics, chemistry, mathematics, geometry, all philosophy, everything, okay? So, Aryabhata may have been in control, according to some historians, of the Nalanda University as well. So he moved sometimes from some places to some places because there were some big observatories at this time. For example, another one was at Taregana as a part of some temple, naturally. So he was a mobile man, we could say. And also he moved to Kusumapura for higher studies at some point and stayed there as well. Actually, his writings were in the form of poems. It's also interesting. It's not like theorems, lemmas, corollaries, as we state them today, okay? They are like poems. He stated everything as poems very nicely. So, many poemists have speculated that University of Nalanda in Pataliputra possessed an astronomical observatory at that time, and Aryabhata was also in the charge of University of Nalanda. You see, there have been a lot of places that he has been to as an astronomer, as a mathematician. Of course, his main book, main publication is Aryabhatiya. It's a book. But unfortunately, like many books from this time, from these centuries, the whole of it could not reach to our time. No one has a copy of full copy of this book. Only some pages, or how we understand what is written in this book is looking at the books written after it, or books written by Aryabhata in different forms. Because in other books, people or Aryabhata himself mentions that in Aryabhatiya book, it is written about this. Okay, so we get the idea that these topics were dealt with in this Aryabhatiya book. Okay, this is how it works, unfortunately, because if you don't see the book, you have to rely on what is written about this book by the same author or some other authors. This is the way it goes in history. It's not very reliable, but it is the only method historians have for the very old history. So this is about what he has done. Of course, a lot of attention because of astronomy. You need certainly trigonometry, plane trigonometry, and spherical trigonometry naturally. Okay. Platonic solids, for example, 5 platonic solids you must study naturally. So 3-dimensional figures, you have to study polyhedra, okay? All geometry, all number theory, all trigonometry. And as a result of this, sometimes quadratic equations, linear equations, equation systems, algebraic methods. Naturally, in this Aryabhatiya book of Aryabhata, there are 108 poems in this book, interestingly. Of course, mathematical poems, not like love poems, for example, okay? They are mathematical poems giving some results and their proofs in the words of the poems, in the lines of the poems. So, for example, the study reveals knowledge about sine tables, okay, arc sine tables, versine tables, this kind of cosine tables. This kind of tables were given by Aryabhata 15 centuries ago. You see, very, very long time ago. At that time, zero was not known very well. Place, tens place, unit place, hundreds place, these were not well known also, okay? So the calculations is very difficult, everything is very difficult, but this kind of guys like Aryabhata, like others, have done tremendous job with these difficulties in mind. So these two books, Aryabhatiya and Arya Siddhanta, are two of his most important writings, and they are still extant. In both publications, he studied mathematics and astronomy in relation with each other. Mathematical equations are used to understand the equations related to the universe, okay, related to the movement of planets, all right? So, the motion of solar system, for example, eclipses, heliocentrism, algebra, value system, zero, trigonometry, equations, number pi, for example. This Aryabhata guessed the number pi up to 3 points. You see, 1, 4, 1, and the rest is 5, 9, as you see, okay? So is the ratio of the circumference and the diameter for any circle, you know, the number pi. So Aryabhata has done a lot of things. His work affected Islamic mathematicians, Arabic and Turkish mathematicians, and Islamic golden age started after Aryabhata. Like Al-Biruni, Al-Harizmi, okay? Both shared the view that Earth revolved on its axis for the first time. They cited 16th, 17th century works, but actually trigonometry and this kind of calculations was in Aryabhata's notes, okay, for the sine, cosine, inverse sine, etc. There were lots of sine, cosine, 1 minus cosine, this kind of tables in the studies, in the publications of Aryabhata. Okay, like for example, jya and kojya are the Sanskrit terms for sine and cosine. You see, this is like sine, this is like cosine. Okay, so the root even, the name even calls Sanskrit. You see, so it cannot be anything else. So this kind of, he's done a lot of things, so I will pass the contributions. You can find most of this in internet, but I just try to give some that I teach to my students. He gave, for example, the circumference of the Earth. He gave orbit of the Earth around the Sun, and he mentioned that these planets move ellipsoidally, okay, in the form of an ellipse. They moved around the Sun. So the orbits are ellipse, for example, for these planets. So because he explained the sunlight, day and night. And yeah, again, elliptical, he mentioned. Lunar eclipses, solar eclipses, he explained for the first time this kind of natural happenings, okay? So until then, this was the cause of the eclipses. According to the people, it was a demon named Rahu, for example. Very interesting. So he also calculated 1 year as 365 days, 6 hours, 12 minutes and 30 seconds, which is only 12 minutes and 30 seconds more than the true value that today we accept. So, second mathematician I will very quickly mention is Brahmagupta, lived a little bit later. He composed the philosophic book Brahmasputa Siddhanta and Kandakadaya, very difficult names you have, Kandakadhyaka, I think. So he was the very first mathematician who developed the area of cyclic quadrilateral, very serious business, okay, for this time. His contributions to geometry were also important. Also, he has done some calculations with zero. In Western mathematics, people think that Al-Khwarizmi in the 10th century found zero. But many, many years ago, Brahmagupta gave calculations with zero. 0 divided by 0, which is indeterminate, we know today, but he mentioned that 0 divided by 0 is 0. This may be a small mistake, but he studied for the first time. No one knows about 0, and this guy comes and divides 0 by 0. Very important step. So he does calculations. For example, he says that a number deleted from itself gives 0, nothing, emptiness, okay? So many rules he gave with 0. So he lived in this city, Billamamala, under this dynasty. So he always focused to find new concepts. So he was interested in something new always. And he lived in South India, in Rajasthan and North Gujarat. So it was also center of institutions for mathematics and astronomy. So this book includes important mathematical teachings, algebra, geometry, trigonometry, algorithms, and lots of astronomical calculations he made about the sun, about the moon, this kind of things. So, yeah, he also done some calculations with squares and cubes of the numbers. Normally, we know that these sums calculated by, for example, German mathematician Gauss in Western mathematics. But 1,000 years ago, then Gauss, these formulae were obtained actually. So this is the power of Indian mathematics. So I was going to talk about Vedic mathematics a little bit, but you know it. I was going to tell briefly because I have another talk right now in another university in India because of the National Day. Unfortunately, they overlapped a little bit, and they are calling me. Maybe you are hearing my phone. So I will stop here. I hope I can give you some idea about Indian mathematics. You are Indian. You must feel the power of mathematics and Indian mathematicians. So with this responsibility as young mathematicians, Indian mathematicians, you must be working very, very, very hard. Okay? So I congratulate your National Mathematics Day and thank you for listening.
Thank you so much, sir, for your wonderful words and for reiterating the contributions of Indian mathematicians to the mathematical history of globe, and for reiterating the point that the researches which have been done by Babylonians, Goths, and many other Western mathematicians were already done by
In 1 minute, I will be joining. Sorry, my other talk is continuing. 1 minute.
Wonderful words and
Sorry.
knowledgeable speech.
So I have to say goodbye to all of you. Hope to see you again because the other talk is starting. I'm really sorry. Another time we can come together online or offline and we can talk more. Hopefully, I can listen to young mathematicians there. Hopefully. So thank you for listening. Thank you for invitation, everything.
Thank you so much.
Thank you. Thank you. Thank you.
Thank you. Okay, now I would like to request